Developing diagnostics often involves many manual steps. But what if your entire diagnostic development flow runs automatically, right? Let me show you. Hello, my name is Ina and I am a diagnostic software development engineer at Vector. In this video, I will guide you through a complete diagnostic development workflow automated in a pipeline optimized for fast and error-free integration. Why use automation in a pipeline? Because every change in the repository triggers the workflow and provides immediate feedback on design and implementation. Fast, reliable, and fully repeatable. Let's look at the complete pipeline, which includes local design and implementation steps on the engineer's PC and 4 build jobs: diagnostic design, build diagnostic specification, build ECU, test, and build tester data. Each step uses Vector tools that seamlessly integrate with each other. We start in Canalys Studio with the authoring of diagnostic data. Once this is completed, we can use the exported text file from Canalys Studio as input for DaVinci Developer Classic to continue with the application diagnostic design. If required, we can add or adjust the implementation matching our diagnostic data in Visual Studio. From now on, the pipeline proceeds to execute all subsequent steps in a fully automated manner. We complete the diagnostic specification by synchronizing the diagnostic data with the design. In this workflow, we want to test and validate our software on a virtual ECU, which is built in the next step. Testing is done afterwards in a separate job. CanoDiva automatically generates test cases which are executed with the Cano Server Edition. This means diagnostic changes are validated automatically without manual test setup. As last job, tester data such as ODX or the offline capability description for SOVD are exported. So let's begin and show the pipeline in action. As an example, we use a door ECU with the function window lift control. This function is accessible via a UDS routine. We create this routine in Canalys Studio. I have opened the CDD file of our door ECU. We navigate to the diagnostic class routines, activate the already prepared routine for window lift control, and save the modified file. We extend the ECU software with our prepared implementation of the routine. Finally, we commit and push both changes to GitHub. This triggers the pipeline run. We can seal all pipeline steps in GitHub: build diagnostic specification, build ECU, test, and build tester data. After the pipeline run is finished, we can download the CanoDiva test report, which immediately shows the impact of diagnostic changes. From a previous workflow run, I already downloaded and opened the old report file in CanoDiva. If we now also open the new report for comparison, we can inspect the differences between the reports. At the nodes Not Comparable and Not in Current Report in the tree on the left side, we can see the additional test cases for the new routine. Our implementation successfully passed the tests. With this automated workflow, diagnostic changes become transparent, traceable, and testable within minutes. If you want to learn more about diagnostic automation, get in touch with us and book a demo. Check the description for more info. Interested in more videos about diagnostics, smart workflows, and overall good software? Then subscribe to our Vector Tech Tutorial channel and activate the bell. Hope to see you there. Bye!